गुड मॉर्निंग बच्चों। आज हम एक इम्पॉर्टेंट टॉपिक डिस्कस करने जा रहे हैं, दैट इज द वांट ऑफ फैक्टर। इस टॉपिक से कम एक न्यूमेरिकल या एक क्वेश्चन जरूर आता है, चाहे वो बोर्ड एग्जाम हो या कोई भी कॉम्पिटिटिव एग्जाम हो। तो जैसा कि हमें मालूम है, चार कोलिगेटिव प्रॉपर्टी जो थी हमारी, दैट इज एलिवेशन इन बॉइलिंग पॉइंट, डिप्रेशन इन फ्रीजिंग पॉइंट, osmotic pressure and relative lowering of vapor pressure, that is was molality multiplied by Kb. This was also molality multiplied by Kf. This was molarity multiplied by ideal gas constant into absolute temperature T, and relative lowering of vapor pressure, that is P1 naught minus P of solution divided by P1 naught was X2, that is the mole fraction of solute present in the solution। तो ये सारी की सारी जो कोलिगेटिव प्रॉपर्टी हैं वो कहीं ना कहीं नंबर ऑफ मोल्स पे डिपेंड कर रही है। दैट इज मोलैलिटी इज नथिंग बट नंबर ऑफ मोल्स ऑफ सोल्यूट पर केजी ऑफ सॉल्वेंट, molarity is number of moles of solute per liter of solution, and this is the mole fraction of solute, which is number of moles of solute divided by total number of moles। so कहने का मतलब है कि जो number of moles of solute particle हैं, they are determining the values of this all the colligative properties। इसीलिए जब हमने 1 मोल ऑफ यूरिया डिजोल्व किया या 1 मोल ऑफ सुक्रोज डिजोल्व किया या 1 मोल ऑफ ग्लूकोज डिजोल्व किया वाटर में, इन ऑल द केसेस द एलिवेशन ऑफ बॉइलिंग पॉइंट वाज फाउंड टू बी इक्वल टू Kb, बिकॉज हमने 1 मोलर सॉल्यूशन बनाया इन तीनों का, और दिस वाज इक्वल टू 0.52 डिग्री सेल्सियस फॉर वाटर। कहने का मतलब है कि चाहे हम यूरिया डिजोल्व करें, सुक्रोज डिजोल्व करें या ग्लूकोज डिजोल्व करें, अगर हम 1 मोल सभी का लेते हैं तो हमारी जो कोलिगेटिव प्रॉपर्टी की वैल्यू है दैट वाज फाउंड टू बी सेम इररेस्पेक्टिव ऑफ द सोल्यूट टेकन। ओके, बट हुआ क्या, जब हमने एक इलेक्ट्रोलाइट सब्सटेंस को वाटर में डिजोल्व किया, मान लीजिए मैंने 1 मोल ऑफ सोडियम क्लोराइड को डिजोल्व किया, तो क्या हुआ, जो मेरा एलिवेशन इन बॉइलिंग पॉइंट था दैट हैज कम 1.04 डिग्री सेल्सियस, दैट इज नथिंग बट 2 टाइम्स ऑफ 0.52 डिग्री सेल्सियस, इस डबल हो गया। तो कोलिगेटिव प्रॉपर्टीज वाज फाउंड ट्वाइस। तो इसका जो है वांट ऑफ फैक्टर यहीं से हमारा शुरुआत हुआ। तो हुआ क्या कि जब NaCl को हमने वाटर में डिजोल्व किया तो वी फाउंड द आयंस ऑफ सोडियम एंड क्लोराइड। तो जब मैंने 1 मोल ऑफ सोडियम क्लोराइड डिजोल्व किया तो मुझे 1 मोल ऑफ सोडियम आयन मिला और 1 मोल ऑफ क्लोराइड आयन मिला, यानी मेरे सॉल्यूशन में जो नंबर ऑफ मोल्स जो हैं वो डबल हो गए। दैट इज वाई द एलिवेशन ऑफ बॉइलिंग पॉइंट वाज फाउंड 2 टाइम्स, बिकॉज वी नो दैट कोलिगेटिव प्रॉपर्टी डिपेंड्स ओनली ऑन द नंबर ऑफ पार्टिकल्स एंड नॉट ऑन द नेचर। दैट मीन्स चाहे सोडियम क्लोराइड का मोल हो या Na+ हो या Cl- हो, इट इज इमैटेरियल। दैट इज वाई द कोलिगेटिव प्रॉपर्टी बिकेम ट्वाइस। यानी अगर मेरा ये है ऑस्मोटिक प्रेशर है और वो मेरा अगर 1 मोल डिजोल्व करने से सपोज 1.5 बार आ रहा था, तो अभी जब मैंने सोडियम क्लोराइड का 1 मोल डिजोल्व किया तो वो ट्वाइस आ जाएगा, यानी इट विल बी 3 बार इंस्टेड ऑफ 1.5 बार। दैट इज द मीनिंग ऑफ वांट ऑफ फैक्टर। तो वांट ऑफ फैक्टर का जो डेफिनेशन आया दैट इज observed colligative property, observed value of colligative property divided by calculated value of colligative property. Calculated means by this formula. Okay, so we can say that the actual formula, because observed value is the real value, calculated value has no meaning. Okay, so we can say that the real formulas for a generalized formulas for the colligative properties becomes delta TB equal to I into M into KB, and delta TF will be I into M into KF, and pi will be I into molarity into RT, and the relative lowering of vapor pressure will be also equal to I times mole fraction of solute. So these are the general formulas, whether it is a electrolyte which dissociates into its ions, or it may be a molecule that gets associated in the solution. We will come to know there are certain substances which get associated in their solution, like acetic acid which gets dimerized in benzene. Similarly, your benzoic acid gets dimerized in benzene, and the phenol also gets dimerized in benzene. So in that case, the values of I will become less than 1. In case of electrolytes, the values of I will be greater than 1. So these are the general formulas. In case of urea or glucose, we can say that I is equal to 1 because they do not associate or dissociate in the solution. So these are the general formulas for the colligative properties which take into account the dissociation or association of the compounds or the solutes. Now I will tell you why this association takes place in the benzene solution. Let us take the case of acetic acid. We know that acetic acids gets dimerized in the benzene. Why? Because if you see the structure of acetic acid, this is CH3, single bond C, double bond O, single bond OH. If I write another molecule of acetic acid, it will be CH3, single bond C, double bond O, single bond OH. Okay, now what happens? This hydrogen will have delta minus, delta plus, and as the oxygen is highly electronegative, it will have delta minus charge. It will pull the shared pair of electrons towards itself from hydrogen. So hydrogen will get delta positive charge, and this oxygen has the lone pair of electrons. So this hydrogen will make a hydrogen bond with oxygen, and similarly this hydrogen will also make the hydrogen bond with this oxygen which has the lone pair of electrons. So this is the dimer of acetic acid in benzene. Similarly is the case with phenol, that is C6H5OH, that also gets dimerized in benzene, and benzoic acid, that is also getting dimerized in benzene, that is due to the hydrogen bonding. So what happens when I dissolve 2 moles of acetic acid in benzene? I will get 1 mole in the solution, because 2 moles of acetic acid will convert into 1 mole of dimer, that is the dimer of acetic acid. So if I want to find the relation between I and alpha, say alpha is the degree of association, okay, then at initially I take 1 mole of acetic acid and there is 0 mole of dimer. At equilibrium, say alpha moles are getting associated. Then I will get alpha by 2 moles of dimer of acetic acid. And what is the total number of moles after achieving equilibrium will be 1 minus alpha plus alpha by 2, which is nothing but 1 minus alpha by 2. Okay, so by this we can determine the relation between I and alpha, because I is nothing but total number of moles after dissociation divided by total number of moles before dissociation, that is 1 minus alpha by 2. Okay, so we can write the Van 't Hoff factor in 3 different forms. Okay, what are the 3 forms? Number 1 I can write as observed colligative property, divided by calculated value of colligative property. Okay, then I can also write this as normal molar mass of the solute divided by abnormal molar mass in the solution. Abnormal molar mass of solute in solution. Okay, because we know that in case of dissociation, this abnormal molar mass of the solute will be almost half, and in case of the association, this abnormal molar mass will be almost double that of the normal molar mass. So in case of dissociation, this I will be greater than 1. In case of association, this I will be less than 1. And the same will be the value of colligative property. And the third form, which is used in our numericals, that is total number of moles of solute before, that is after dissociation, total number of moles of solute after dissociation oblique association divided by total number of moles of solute prior to before dissociation oblique association. So that is the general formula for Van 't Hoff factor. In case of the dissociation, the total number of molecules after dissociation will be more, so I will be greater than 1. In case of association, total number of moles after association will be less than 1. It may be half. In case of association is 100%. The degree of association is 100%, then the I will be 0.5 in case of association. Okay. Now let us derive the relation between I and alpha or some electrolytes. Okay, let us assume that you are given the electrolyte sodium sulfate, which gets ionized or dissociated into sodium ion and sulfate ion. Okay, Na2SO4 means we will get 2Na plus and SO4 2 minus. Let the initial number of moles will be 1 and this is 0, and at equilibrium let alpha moles get dissociated into the ions. So we will get 2 alpha moles of sodium ion and alpha moles of sulfate ion. So what is the value of I? That is the total number of moles after dissociation divided by total number of moles before dissociation, that is 1. We started with 1 mole, so I will be nothing but 1 plus 2 alpha, that is for sodium sulfate. Similarly, we can calculate the values of I for other substances. Let us calculate the one for, say, K4FeCN6. We know that this is a coordination compound and this is the ionizable valency is outside the square bracket. So let us assume that this will dissociate into 4K plus and FeCN6 4 minus, that is the anion. Let us assume we start with 1 mole of K4FeCN6. We have 0 and 0 initially. Let alpha moles get dissociated. So we will get 4 alpha of potassium ion and alpha of this ion. So the total number of moles will be 1 minus alpha plus 4 alpha plus alpha, and that is the value of I, which is nothing but 1 plus 4 alpha. So in this way we can calculate we can find out the relation between want-off factor and the degree of dissociation. Suppose I want to find a relation between degree of association and alpha, then that also we can find out. Suppose I write 2 moles of acetic acid get dimerized in benzene to give 1 mole of dimer of acetic acid. Okay, let we start with 1 mole of acetic acid. Initial moles of dimer is 0. Say at equilibrium alpha moles get associated, so I will get alpha by 2 moles of the dimer. So what will be the value of I? That will be 1 minus alpha plus alpha by 2, that is nothing but 1 minus alpha by 2. So that is how we can find the relation between want-off factor and the degree of association or that of dissociation. Okay, now we take some past year questions which were asked in the JEE main exam of IIT, that is 2017. The question is, it is given that the freezing point of benzene gets reduced by 0.45 degrees Celsius when 0.2 gram of acetic acid was dissolved in 20 gram of benzene. Okay. Now it is said that it is assumed that the acetic acid gets dimerized in benzene, and what is required to be found out is the percentage of association of acetic acid is to be found out. That means alpha is to be found out. If alpha is the degree of association, and the value of Kf, that is molar depression constant for benzene, is given as 5.12 Kelvin kg per mole. So what we will do? We will apply this formula. Depression in freezing point is nothing but I m Kf, where I is the want-off factor and m is the molality and Kf is the molar depression constant for benzene. Kf is already given to us and the delta Tf is also given to us as 0.45 degrees Celsius. So molality we can find out. Molality is number of moles of solute, that is 0.2 divided by molar mass of acetic acid upon kg of solvent, that is 20 grams, so 20 divided by 1000. So that is the molality of this solution. Now we know the relation between I and alpha we just found out for acetic acid. dimerization, it is 1 minus alpha by 2. So I put these values in this equation. I will get 0.45 is equal to, in place of I will write 1 minus alpha by 2 multiplied by molality, that is this 0.2 upon 60 divided by 20 upon 1000 multiplied by Kf. Kf is 5.12. We can solve this equation and find the value of alpha, which will be 0.946. So the answer is 94.6% is the association of acetic acid in benzene. So that is how we can find out the degree of association. If the value of molality is given to us and the value of colligative property is also given to us, that is delta Tf or any other colligative property. Okay, now the next question we take is that was asked in 2019 main, and this is K2HgI4 is 40% ionized. The value of Hoff factor I is, 4 options are given to us, that is 1.6, then 1.8, then 2.2, then 2.0. How we will do? We will write this equation, the relation between I and alpha, that we will find out for this a coordination compound. This is a coordination compound, and let it gets dissociated into 2K plus HgI4 2 minus. We know that this is the ionizable valency which is outside the square brackets, and this is the coordination sphere. So if I start with 1 mole, I have 0 and 0. Say at equilibrium, alpha moles of this compound gets dissociated, then I will get 2 alpha of K plus ions and alpha of this anion. So the I will be nothing but 1 minus alpha plus 2 alpha plus alpha, that will be 1 plus 2 alpha, and it is given alpha as 0.4 because it is 40% ionized in water. So what will be I? That will be 1 plus 2 alpha, that is 1 plus 2 into 0.4, and this comes to be 1.8. So B option is correct. Okay, so that is how we can solve this type of numericals, by finding a relation between I and alpha, that is the Hoff factor and the degree of dissociation or association. Now we take 2 more questions, then we will conclude this session. This question is 0.04 molar Na2SO4 solution is isotonic with. What is the meaning of isotonic? Means it has the same as osmotic pressure as this solution with 0.1 molar glucose solution. Okay, these two solutions have the same osmotic pressure at a given temperature. Okay, because osmotic pressure depends on temperature also. And what is asked is what is the apparent degree of dissociation. What is the apparent degree of dissociation? That is alpha is asked for sodium sulfate. So that is our question. Okay, so how we will go about? We know the formula for osmotic pressure is pi equal to I into molarity into RT. Here temperature is constant because at a given temperature, so we can say that pi 1 equal to I1 M1, or we can say pi 1 is directly proportional to I1 M1 and pi 2 is proportional to I2 M2, where M1 is the molarity of first solution, that is Na2SO4, that M1 is given as 0.04, M2 is given as 0.1 for glucose solution, and we know that for glucose I2 equal to 1 because glucose neither associates nor dissociates in the solution, and so this they are isotonic, so we can say that pi 1 equal to pi 2, so we can say that I1 M1 equal to I2 M2. Okay, because temperature is constant, so we can find out the value of I1, which is nothing but I2, that is 1, into M2 is 0.1 divided by M1, that is 0.04. So I1 is coming as, this will be 10 by 4, that is 2.5. So this is the value of I1, and now I find the relation between I and alpha for sodium sulfate. Let this get dissociated into 2Na plus SO4, 2 minus initial 1 0 0, 1 minus alpha, 2 alpha, alpha. So what is the value of I? 1 minus alpha plus 2 alpha plus alpha. This is nothing but 1 plus 2 alpha. So I1 is nothing but 1 plus 2 alpha, that is 2.5. So 2 alpha is equal to 2.5 minus 1, that is 1.5. So alpha will be 1.5 by 2, that is 0.75. So that is our answer. So the apparent degree of dissociation is 0.75. Okay, so that is how we can find the value of degree of dissociation of a given electrolyte. Okay, now I take the last question, the last numerical, which is also related to the coordination compounds, and this was asked in 2018 main exam. Here it is written that for a 1 molar aqueous solution of the following compounds, which one will show the highest freezing point? Which one will show the highest freezing point? Okay, the highest freezing point means the depression in freezing point should be lowest, then only it will show the highest freezing point. So the given solutions are A, that is cobalt H2O whole 6 Cl3, and B is cobalt H2O 5 whole 5 into Cl2 into H2O. So one H2O molecule has come outside the coordination sphere, and C is CO H2O 4. Here there will be Cl into 2H2O, and thus Cl will go inside of this, and here Cl2 will go inside of this, and D CO H2O whole 4. Here all 3 molecules of Cl chloride are inside the square bracket into 3H2O. Okay, here H2O will be 3. So 3 H2O has come outside the square bracket. We know that for coordination compounds, the entity outside the square brackets, that is called the counter ion, that is only ionizable. So if I write in case of A, when it is dissolved in water, okay, what ions it will produce? This will produce 3 chloride ions plus 1 this cation. So this will have 3 plus charge. Okay. So total number of ions produced is 4 in this case. 4 ions are produced. In this case 2 plus 1, that is 3 ions are produced. In this case 1 plus 2. Sorry, 1 plus 1, that is 2 ions are produced. In this case there is no ionizable valency outside the square bracket, so only 1 ion will be produced. So if I write delta TF equal to IMKF, then delta TF is proportional to I, and I is proportional to the number of ions produced. So I will be maximum for A and I will be minimum for B. So when the value of I is minimum, then delta TF will be minimum, and when delta TF is minimum, then the freezing point will be maximum. Because the depression in freezing point is minimum, then only the freezing point it will show highest value. So the correct option is B, because in this case the I value is minimum, delta TF is minimum, that is why the freezing point is maximum. So that is how we can solve this type of questions. Okay, now I ask you last one question, which is qualitative. It is not a numerical. Suppose I give you 1 mole of 3 acids. Okay, 3 derivatives of acids. Number 1 is acetic acid, which is CH3, COOH, and number 2 is your say trifluoro acetic acid, which is CF3, COOH, and third is trifluoro acetic acid, which is PCl3, COOH. Now which will have the highest value of depression in freezing point? Okay, we know that depression in freezing point is IMKF. Now 1 mole of each is dissolved, so molality is same, KF is same because we dissolve in water, so KF is same, so delta TF is proportional to I. Now which will have the highest value of I? This will have the highest value of I, that is trifluoroacetic acid. Why? Because the electronegativity of fluorine is maximum, and as compared to chlorine and hydrogen is minimum. So what will be the order of delta TF? That will be CF3COOH, that is trifluoroacetic acid, will be higher than CCl3COOH, will be higher than CH3COOH. This is because this, if I write the structure of CF3COOH, it will be like this: CH3, C, double bond O, single bond OH. This fluorine being highly electronegative, it will pull the electrons. So the polarity on this OH bond will be more, this oxygen will become more electronegative due to minus I effect of fluorine. So the hydrogen ion, it can release easily. So we can say that alpha of this is greater than the same is the order of alpha, and if the alpha order is same, that is this that is the degree of dissociation, then what is I for this? I is equal to 1 plus alpha, because CH3COOH gives CH3COO minus plus H plus, that initial mole be 1 0 0, and this is 1 minus alpha alpha alpha, so I will be equal to 1 plus alpha. So I is 1 plus alpha, and alpha is maximum for this, so I will be maximum for this, and the delta TH will be maximum for this. So that is how you can determine the effect of more electronegative element attached with this derivative, that is the derivative of acetic acid. So alpha will be more for this, will be highest for this, and will be minimum for this, and the same will be the order of Van-Hoff factor, and the same will be the order of colligative property. With this we conclude our session here. If you have any doubt, then you write in the comments and we will try to sum it up. Okay, thank you, wish you all the best.